Okay, so today we're going to continue on with the notes, chapter 6 notes. This is part 2 of it. Something called exothermic process, or what the term exothermic versus endothermic means. So the term exothermic, thermal, just think heat, okay, like thermal energy is heat. I think I shouldn't have pushed it there. That's okay. Oops. So thermal chemistry is heat change in a chemical reaction. Okay, so thermal energy. Exo is outside. You might have heard the term exoskeleton. So that's a hard parts on the outside. Think of like bugs. Okay, there are hard parts of the bugs on the outside of the bugs, or insects, I should say, maybe not bugs. The hard parts of the insect is on the outside. Humans have an endoskeleton. Our hard parts, our skeletons, are on the inside of our bodies. Okay, but exo, outside heat process. Any process that gives off heat. So heat is on the outside. It gives off heat. Most reactions, I think I mentioned it last time, most reactions are actually exothermic. That means it transfers thermal energy from the systems to the surroundings. So again, the surroundings are the outside. Okay, the surroundings are the outside. And so heat is going out to the surroundings. So heat is given off. And so, in other words, heat is a product. Heat, energy. Energy is a product. And if energy is a product, it is called an exothermic reaction or exothermic process. Thermal energy is from the system is transfers to the surroundings. So heat or energy, here is written in this equation, energy, but sometimes written as heat, and we're going to write it later on a different way. But this is hydrogen and oxygen makes water. This is burning of hydrogen. In the picture last time about the Hindenburg exploding, that's hydrogen. Hydrogen reacting with the oxygen, it sparks somehow. It releases lots of heat. All burning, okay, explosions, whatever, release lots of energy or heat. So exothermic reactions, energy is transferred to the surroundings. This is gaseous water turning into liquid water, condensation. Condensation is actually also an exothermic reaction, which is why in a shower, or if you go to a steamy, into a steam bath or whatever, what is that called, a sauna, it feels warm because as water goes from a gas form into a liquid form, it releases energy. It gets hotter, okay? So I'm not sure it's called a sauna, whatever, the steam room, whatever it's called, okay, at a spa. So, or just even walking into a steamy bathroom, it feels warm because as it goes from a gas to a liquid, it releases energy. So if it releases energy, it's a exothermic reaction. So energy is transferred from the system to the surroundings. What's the opposite of exothermic? The term is called endothermic. Endothermic is a process in which heat has to be supplied to the system from its surroundings. So an endothermic reaction would be you're using energy from the surroundings. Energy, and this is mercury oxide, okay, technically mercury 2 oxide, turns into mercury and oxygen. Heat is required. Okay, heat is required to basically break apart mercury and oxygen to turn into mercury oxide into mercury and oxygen. Here's another one you might know. Energy is required to turn H2O solid into H2O liquid. Solid water into a liquid water. What's solid water? It's ice. Okay? Liquid water, how do you melt ice? You need energy from the surroundings. So if I had a giant block of ice in the room, yes, it'll melt. Where does the energy come from to melt the ice? From the room. Yes, the room would get colder. Okay? Because energy from the surroundings must be supplied, or energy has to be supplied from the surroundings. So if I had a block of ice in a room, I had an ice sculpture. I don't know why I have an ice sculpture, but I have an ice sculpture in the room. It will start melting because energy in the room will start melting it, and it will cool down the room. Okay, So if I had a giant block of ice and it was a hot summer day, I guess, yes, it'll cool down the room somewhat. Okay. And so, yeah, so endothermic reaction, opposite of exothermic reaction. Exothermic reaction, the surroundings get hotter, energy is released, energy is a product. Endothermic reaction, energy supplied from the surroundings, so energy is a reactant, so it will use up energy, the surroundings will get colder. If it absorbs energy from the surroundings get colder. So exothermic reaction, you touch it, ooh, it's warm, or, you know, that's the idea of it. You touch some endothermic reaction, oh, it's cold. Most reactions are exothermic. Okay, let me move my face. Okay, so energy. If heat is given off, okay, these are two separate pictures, the left side and right side. So if heat is given off to the surroundings, that thing, again, is called an exothermic reaction. So the products overall have less energy than the reactants. So if the products, whatever they are, hydrogen and oxygen, and these are the same ones, right? Oh, well, my face is on top of it. So, oops. Okay, well, whatever. Hydrogen and oxygen makes that water. So hydrogen and oxygen makes that water. This is the thing that's in the Hindenburg. So if the products have, if it gives off heat, overall, the products have less energy. That's exothermic reaction. In an endothermic reaction, the products absorb energy. The products, the reactants absorb energy to turn into the products. So overall, the products have more energy than the reactants because it absorbs energy from the surroundings. So overall, in an exothermic reaction, your products have less energy than what you start off with. In an endothermic reaction, the products have more energy than the reactants overall. That's going to be important later on, but I'm just pointing it out right now that heat in an exothermic reaction, it releases heat, so, well, the overall must have less heat or energy. An endothermic reaction absorbs heat energy, so the stuff overall at the end must have a little bit more energy. Okay, term enthalpy. Enthalpy, symbol is H. Okay, we'll be using H for enthalpy, not E. E is energy. So enthalpy. Enthalpy is used to quantify the heat flow in or out of a system that occurs at constant pressure. For our purposes, we'll call enthalpy and heat kind of the same thing. Technically, they are not the same thing. Okay, what's the difference? Take AP Chem for that. We're not going to get into that right now. But yes, there's technically a difference between heat and enthalpy. Okay, but for our purpose right now, heat and enthalpy going to be the same thing. Heat and enthalpy for the purpose for right now are the same thing. It's kind of like saying mass and weight are the same thing. No, they're not. What's the difference? Well, you do know the difference between weight and mass. That's something you also learn in physics. It has to do with gravity. Heat and enthalpy are not technically the same thing, but for the point of what we're going to do right now, for now, we'll call it the same thing. There is a difference. If you take AP Chem, you will learn it there, but we're not getting into that right now. Okay? So, in fact, because of that, I actually just call this heat for our purposes, but technically the term is enthalpy. It's kind of, again, like weight and mass. Probably should use the term mass, but lots of times I just say weight. Okay, so enthalpy is a heat flow in or out of system. So, oops. Okay, so the change in heat, technically enthalpy, okay, fine, I'll use the term enthalpy. The change in enthalpy is the enthalpy or heat of all the products minus the enthalpy or heat of all the reactants. The change in enthalpy is the heat of all the products, enthalpy of all the products minus heat or enthalpy of all the reactants. In a exothermic reaction, oh, by the way, this is assuming constant pressure, okay? Constant pressure is, when things are at constant pressure, enthalpy is heat. We're going to assume all reactions are at constant pressure. It's kind of like on Earth, weight and mass are the same thing. When you're off of Earth, technically they're not the same thing anymore. Okay, so this chapter we're going to assume everything's at constant pressure. If it's not constant pressure, what do? Take AP Chem. That's not the point of this thing right now. Okay, so you'll learn in AP Chem, not here. So in an exothermic reaction, this is an exothermic reaction, that heat is given off to the surroundings. The products have less energy than the reactants. So if this is a smaller number than that number, when you take a smaller number, subtract a bigger number, what do you get? Delta H will be a negative number. Okay, delta H or the enthalpy, change in enthalpy, will be a negative number. We'll be seeing that when we see chemical reactions, that you'll see a delta H next to a reaction, and it'll be some positive or negative thing. Okay, if it's negative, that means it's an exothermic reaction. So delta H is negative, it's an exothermic reaction. In an endothermic reaction, heat is absorbed, so overall the products have more energy than the reactants. So in an endothermic reaction, since it absorbs energy, those products have more energy than its reactants do. And if the products have more energy than the reactants, if products are bigger than reactants, big number minus small number, overall you'll have some positive delta H. So if you see a reaction, you see, hey, delta H is some sort of positive number, that means it's an endothermic reaction. If delta H is a negative number, that means it's an exothermic reaction. Negative exothermic, positive endothermic. Negative exothermic, positive endothermic. If delta H is negative, it's exothermic. If delta H is positive, it's endothermic. So if delta H is negative, it's exothermic. If it's positive, it's endothermic. Okay, look at this picture. Heat is absorbed from the system. Is delta H positive or negative? And since heat is absorbed, that means the products have more energy than reactants. It absorbs heat. It says so. Energy is absorbed. So if the products have more energy than the reactants, this is an endothermic reaction. So we just said, if it's endothermic, delta H will be a positive number. Here's the example of how it'll be written. If 6.01 kilojoules of energy are absorbed for every 1 mole of ice that melts at 0 degrees Celsius and 1 atmosphere, this is how we would write it. Okay? I would write the equation as, we're talking about ice melting. H2O solid, that's ice. Turn to H2O liquid, that's water. Ice melting, this is coefficient 1. 1 mole of ice turning into 1 mole of water. Okay. Well, how do I mention that 6 kilojoules, 6.01? 6.01 kilojoules of heat are absorbed. What we write next to the equation is this. Delta H is equal to positive endothermic positive, it absorbs heat. Delta H is equal to positive 6.01 kilojoules. So you will see in a chemical equation, they should be balanced. You'll see a balanced chemical equation, and next to the balanced chemical equation, see delta H is equal to some number. Okay, positive endothermic, negative exothermic. So positive endothermic, negative exothermic. Here's another example. Is delta H of this given picture there negative or positive? Well, I see heat is given off to the surroundings. If heat is given off, this thing is exothermic. If heat is given off, something's burning, it gives off heat. Okay, so it's exothermic. Exothermic delta H is negative. So if you had the statement, this is just given right now, 890.4 kilojoules of heat, okay, or kilojoules, kilojoules is a measure of energy, joules is a measure of energy. So 890.4 kilojoules of energy are released for every 1 mole of methane that is combusted at 25 degrees Celsius in 1 atmosphere. Okay, you didn't know what methane is, but CH4 is methane. So how I would write it is this. 1 mole of methane and oxygen, which by the way makes carbon dioxide water. So this is, even if you didn't know the equation, this is it. It's just given here right now. 1 mole of methane and 2 moles of oxygen makes 1 mole of carbon dioxide and 2 moles of water. Okay, and that's actually is written right there in the given. How do I write that 890.4 kilojoules of heat are released? All I do is right next to the equation, you put delta H is equal to negative 890. The negative sign only signifies as exothermic. Positive endothermic, negative exothermic. Positive endothermic, negative exothermic. Exothermic means heat is released, heat is given off. The surroundings get warmer. Okay, so I think we'll just stop for here for now.